Hi everyone, my name is Julia Böke and I'm an early-stage researcher in the MonPlas project. I'm doing my PhD on the analytics of microplastics here at the Leibniz Institute of Photonic Technology in Germany. Last year I explained to you what my project is about, and now I'm going to show you the progress I made over the last 1.5 years. During my PhD, I work on multispectral imaging flow cytometry for micro and nanoparticles. That means that we use glass chips like these to manipulate fluid streams with and without particles and observe them with high-speed cameras and afterwards analyze the images using image processing methods. Therefore, my first project was all about understanding and controlling the fluid streams in microchannels. We developed a software tool, the Microfluidic Network Solver. Similar to methods of electronic design automation, we interpret our microfluidic chip as a network of resistances. Our solver applies Kirchhoff laws to the entire network of the microfluidic chip and calculates the pressure distribution from the feed lines over the chip to the waste outlet. All in all, we showed that this solver also enables the prediction of control parameters for operating lab-on-a-chip devices. No matter if we analyze bioparticles, nanoparticles, or microplastic particles, our image processing methods are very similar. In my most recent project, we analyzed the microalgae Haematococcus pluvialis, and in its original state, it's very small and green, but under stress conditions, it starts to change and becomes bigger and red. So with our microfluidic systems combined with imaging flow cytometry, we were able to track the morphological and spectral changes of the microalgae over the entire process for different stress parameters. But now on to microplastics. We developed a standard operating procedure with which we can prepare microplastic particles in our lab. These microplastic particles have a very irregular shape, so we can use them as reference materials for our analysis and for our measurements here. We validate the quality of our reference materials using spectroscopic methods. These past few months I spent in Denmark at Aalborg University for a research collaboration. I stained microplastic particles there and developed a reproducible routine that worked for our labs here in Germany as well as for the labs there in Denmark. Now I work on well-defined microplastic references and developed image processing methods for it. In my next part of the project, I will apply all these methods that I've told you about already and apply those for different microplastic materials and use our imaging flow cytometer to evaluate and analyze them. So overall, we image particles in flow. We track them, analyze their size, color or movement. And whether those particles are microplastics, cells or nanoparticles in high throughput, all of these are able to be analyzed with our setup. Thank you very much for your attention.